Hello everyone, my name is Franco Pucci. I'm the technical consultant for the STS Association and I've been involved in the prepayment industry for over 25 years. Welcome to the STS training video series where we will explore all aspects of the STS and the STS standard. I hope you find these videos helpful. In this video we will deal with section 6 of the 2055-41 edition 3 keychange tokens. The reference source obviously is the IEC document. Okay, so keychange tokens for a 64-bit decoder key, and that's contained in clause 6.2.7. Decoders can support either a 2 keychange token set or a 3 keychange token set. For the 2 keychange token set, it supports the set first section decoder key and the set second section decoder key. And for the 3 keychange token set, we've added the set third section decoder key. Let's look at each of these in turn. So the set first section decoder key, which is 6.2.7.2, you have a class which is class 2, a subclass which is 3, then you have a key expiry number, high order 4 bits, a key revision number from 1 to 9, which is 4 bits, a rollover bit, which indicates whether this is a rollover key change or not, so that can either be a 0 or a 1, a 3 KCT bit, which indicates whether this token is part of a 3 key change set or a 2 key change set. So if it's a 0, it's a 2 key change set. If it's a 1, it's a 3 key change set. The key type 0 to 3, the new key, the high order 32 bits of the new key that you want to change the meter's key to, and a CRC. So the action of this one is load the decoder key register with the first half of the new decoder key. That's new key high order. So if Ken, for example, is 0xC5 in hex, then you set key expiry number high order to 0C, and the next token that you send in will have the 0x05 for the Ken. Rollover bit, if that's set to 0, this is not a rollover key change, and if it's set to 1, this is a rollover key change. 3 KCT, if it's set to 0, it's a 2 key change token set, and if it's set to 1, it's a 3 key change token set. Okay, so remember, there's only the first half of the Ken that goes in this token. The rollover bit is not set by you, but it's set by the security module, and that is done if it detects a base date change. It'll automatically set this rollover bit. You cannot set it externally. And then third of all, if your meter is allowed to do a 3 or supports a 3 key change set, then once again your point of sale will know this, and it will set that bit to indicate that it's part of a 3 key change token set. The set second decoder key, which is described in 6.2.7.3, again you have a class and a subclass, that is class 2, subclass 4. Now you have the key expiry number low order bits. You have a tariff index, which is 8 bits, 0 to 99. The new key, the low order 32 bits, and a CRC. The action here is to load the decoder key register with the second half of the new decoder key. In this case, if Ken was originally C5, as you remember, in the first token we set the C. In this one we're setting the 5. So you concatenate the 2 and you'll end up with the final value of C5. Now the third section decoder key, 6.2.7.4, is an addition to edition 3 of the specification, and this allows you to send the supply group code along with the key change tokens. With 2, there was not enough payload space, so we couldn't send the new supply group code. In this one you can. This is a class 2 subclass 8 token. It has 24 bits, which can be used to send the supply group code from 0 to 999999, and the rest of the 20 bits are reserved and must be set to 0. The action here is to load the decoder key with the new supply group code number. Supply group code values 1 million to that large number are for future assignment by the STS Association and have not been used for the moment. Note that two key change token sets do not set the new SGC value in the decoder when a key change is done. The SGC is set to 0 with a two key change token set, and this is important. If you do a key change on a two key change token set meter, the meter does not know what the new supply group code is, and it therefore cannot leave it as the old supply group code, so it sets it to 0. Anybody looking at that meter and requesting its supply group code, if it gets a valid supply group code, it means it's either had a 3 key change token set or it has not been key changed yet from its original supply group. If it gets a value back of all zeros, it means it has key changed and it has been a 2 key change token set. The 3 key change token set allows the new SGC to be stored in the decoder. For a 128-bit decoder, in other words using EA11, clause 6.2.8, and it supports a 4 key change token set. Okay, and that will be set first up to set fourth section decoder key. So let's look at these. The set first, again you have a class, which is a class 2, subclass 3 in this case, key expiry number high order, key revision number, the rollover, reserved bit, key type, new key high order bits, and the action is to store the last quarter of the new key. Remember, the keys now are much larger than they were before. Once again, if the ken is C5, you first set the C. If the rollover bit is set to 0, it's not a rollover key change, and if it's set to 1, it is. Res B is set to 0. For the new key, you need to concatenate the key values in 4 different tokens: the high order, the middle order 2, middle order 1, and the low order. So all 4 tokens will contain a quarter of the new key because it is a 128-bit key. The second one is a class 2 subclass 4. It's got the key expiry number low order, so you would set the 5 in this case. It has a tariff index and the new key low order 32 bits. Okay, so you set the 5 with the ken, and the new key, as we've already seen, is a concatenation of all of these quarters of keys. The third one, you have a supply group code in this case that is now contained in there, and it's 12 bits of the supply group code, not the full 24. And you have another portion of the key, which would be the middle order portion of the key. For the supply group code, you would concatenate the SGC LO of this token and the SGC HO of the next token, the fourth one. And for the new key, as before, you concatenate all 4. So you can't do any concatenation yet, unfortunately, for both the supply group code and the new key, because you haven't received all 4 tokens yet. Only once you've received all 4 can you then combine the SGC halves into the final SGC value and the key quarters into the final key value. And there's the fourth one, which has the high order SGC value and the last portion of the new key, and then you can do the supply group concatenation and the new key concatenation. Things to note with key change tokens: there's no TID in the tokens. Why not? Because you really don't need. If you've already done a key change, doing it again just simply won't work. So you cannot replay the tokens anyway. A meter only changes the key once all of the tokens have been accepted. So don't start the process of changing your meter key the moment you get one token, because if the second one, or if you forget to enter the second one and go for a cup of coffee and you time out when you come back, you could have a problem. There's usually a 10-minute key change timeout where the meter will stop the key change operation if all tokens have not been entered. Okay, this stops the meter from being in a state where it doesn't, you don't know what the next token you're going to put in is, and it could cause problems. So it times out between 3 and 10 minutes after the start of the key change operation. But we'll talk about key change rules in a later video. What is a rollover key change? I think this is quite important, so let's have a look at it. So if you look at this, you have a TID counter with, in this example, a maximum of 99 minutes, but of course in the real world it's 31.8 years or so. And you start with, in your TID memory, all zeros. You enter the first token and it puts a 1 in, the second token it puts a 2 in, and so on until you get to token 999, and now you have a value of 999 in the token counter. But now what happens when you enter the next token? Well, it now goes to 1000, which means the TID counter, because it only supports 3 digits, will look like a 0. Okay? So, let's go through it again. You have a new base state, so the TID memory is reset to the new base state, starting at all zeros. The TID of each token that is entered is recorded in the TID memory, and that'll start at number 1, number 2, and so on until it gets to the end. At 999, it reaches the maximum TID count of that token. The very next token you put in will look like a 0, since the token only allows for 999 as a maximum TID value. In a real token, this is 31.8 years. If the rollover bit is set, the meter will first of all clear this TID memory that you can see of all its values and set them all to 0. Because now effectively you're starting on a new base state and you want to reset everything to 0. It'll then change its key so that you cannot reuse old tokens. Remember, you may have tokens in your cupboard and now you reset the entire TID stack. You come back and replay one of the tokens. If you have not changed your meter key, that token will be re-accepted again because your TID stack is starting from 0. So, when you're doing a rollover key change, there are 2 operations you need to do. You must clear the TID memory, number 1, and you must change the meter key. You cannot simply do one or the other. This brings us to the end of this part of the video series. I hope you found this video helpful, and I hope you'll join us again for the rest of the series. Goodbye and see you again.